What really causes the moon to have so many different faces? While our constant companion is known to us as always presenting only one and the same side, its hidden reverse side has been accompanied by adventurous theories and speculations since time immemorial. But now, excitingly, researchers may have made a decisive breakthrough in solving the tantalizing moon mystery. Because as we now know, the South Pole Aitken Basin hides a surprising secret underground. According to this, a colossal structure slumbers on the invisible side of the satellite, which on the one hand provides a deep insight into the turbulent past of the celestial body, and on the other, could explain why the two halves of the moon differ so dramatically from each other. What today takes just a few clicks of the mouse was an unsolved mystery for thousands of years. While we are now in the comfortable position of being able to marvel at the far side of the moon from the comfort of our living room couch, our ancestors simply had no way of catching a glimpse of the dark side of our faithful companion. This is simply because the moon has a bound rotation, and as a result, it always turns the same side towards us. In detail, however, the celestial body was not always so shy about its side. In fact, after its formation, the satellite may have rotated much faster before it was slowed down so much by the Earth's gravitational pull over time that its rotational speed approached its orbital speed. However, since eyewitnesses from this distant lunar era are in short supply, humanity had to wait until October 7, 1959, before the Soviet spacecraft Luna 3 revealed the mysterious far side of the moon for the first time in history. 60 years later, Chang'e 4 was the first space probe to land on the dark side of the moon, even though, strictly speaking, it's not as dark as it is often said to be. In fact, the side of the moon facing away from the Earth goes through exactly the same lunar phases as the side that shines towards us in the sky every evening, only in the opposite sequence. In fact, the far side of the moon has a higher reflectivity on average than the near side, which simply means that the hidden area shines brighter at new moon than the visible side at full moon. This is due to the different compositions of the two halves of the moon. Although the word halves is not quite correct in this context, due to the moon's orbit being tilted at 5 degrees and its elliptical shape, only 41% of the moon's surface is visible from Earth. And yet, those 41% are enough to see that the front side of our satellite is adorned with dark spots that are as extensive as they are countless. These are in turn so-called Maria, lowlands covered with solidified lava, and thus structures that are much less common on the opposite side. At the same time, the far side of the moon also has significantly fewer lunar mountains and rills. For decades, researchers have been trying to get to the bottom of the reasons for these confusing differences. But now, and this is the exciting part, experts believe they have finally solved the mystery of the different lunar hemispheres. And the reason for it lies dormant in a hidden giant structure deep below the lunar surface. The gigantic structure on the far side of the moon. For many vacationers, Hawaii is the ultimate travel destination. No wonder, because the enormous main island, which covers over 10,400 square kilometers, not only boasts fascinating black sand beaches, but also one of the largest active volcanoes on Earth, Mauna Loa. But what does a paradisiacal vacation island in the Pacific actually have to do with an extraordinary discovery on the far side of the moon? Well, the answer is surprising. And Peter B. James of Baylor University in Texas sums it up as follows. Imagine a pile of metal 5 times larger than the main island of Hawaii and bury it underground. That's roughly the unexpected mass we discovered. The keyword pile of metal might make some people think of a gigantic spaceship that once crashed into the surface of the moon, but it's not quite like that. To understand what the unexpected mass is really about, we first have to visualize its location. It is not just any location. It's the South Pole Aitken Basin, and thus the largest preserved impact crater in the entire solar system. There is no question that this, with an incredible extent of more than 2,000 kilometers, still bears witness to a violent cosmic crash today. What is much more questionable, however, is how exactly the brutal impact occurred an estimated 4.3 billion years ago and what effects it had on the further development of the then-still-young moon. To get closer to solving this exciting mystery and to explore the nature of the subsurface at the south pole of the moon in the same breath, Peter James' team analyzed data from the Gravity Recovery and Interior Laboratory (GRAIL) mission. In September 2011, two space probes had set out for the moon to study its gravitational field and anomalies and to provide valuable new insights into the internal structure of our satellite. The bottom line is that the experts combined the GRAIL data with those of the Lunar Reconnaissance Orbiter, which has been in operation since 2009, to map the entire lunar surface in high resolution. And as mentioned, James' research team ultimately identified a gigantic mass anomaly deep below the South Pole Aitken Basin. And just so we're all on the same page, we are talking about a structure that reaches a depth of 200 kilometers and weighs a whopping 2.8 quadrillion tons. For comparison, the mass of the entire Earth's atmosphere is estimated at around 5.15 quadrillion tons. But what on earth is hidden in the invisible world of the moon's surface? Well, that probably depends on who you ask. While the more alternative minds think it's possible that we are actually dealing with a hidden base of an unknown lunar civilization, the conservative experts take a more natural approach. More specifically, this refers to the metallic core of the asteroid that created the colossal impact basin in the distant past. And this is by no means a vague approach, but rather the result of a computer simulation that showed that such an iron-nickel core could penetrate deep into the moon's upper mantle during an impact, but without necessarily sinking into the core of the celestial body. In this context, the sheer weight of the asteroid's core could additionally pull the bottom of the crater almost a kilometer deeper into the ground. So far, so plausible. And yet, it should be noted at this point that the experts are also discussing a second theory in this regard. This is based less on an asteroid core and more on an enormous clumped accumulation of dense oxides that once bundled at the moon's south pole as the original magma ocean cooled and solidified. Have we solved the mystery of the moon's hemispheres? Future research will have to show which theory is ultimately correct. However, if we are dealing with a relic of an impact, it could also help us to understand the confusing differences between the sides of the moon. In addition to the unevenly distributed Maria, we now also know that the crust on the near side of the moon is considerably thinner than that on the far side. In the same breath, however, we also find a crust on the Earth-facing area that is enriched with unusually high proportions of radioactive thorium, potassium, phosphorus, and rare earth elements. But how this so-called creep terrain came about is just as unclear as the question of what set the lunar volcanism in motion in the first place. Some experts estimate that the differences in the moon's crust can be traced back to the tidal forces of the Earth. But others see a catastrophic impact as the most promising explanation. One of them is Matt Jones from Brown University in Providence, who, together with his colleagues, investigated the impact of the gigantic heat of the impact at the moon's south pole on the entire celestial body. Interestingly, the South Pole Aitken Basin is almost exactly opposite the region known as the creep terrain. So perhaps we are dealing here with a coincidence that is not really a coincidence at all. The subsequent reconstruction of the impact was based, in turn, on geophysical models of the early lunar interior. And it ultimately revealed something remarkable. Yes, the collision could indeed have triggered a thermal anomaly in the lunar mantle, which significantly influenced the development of the moon's interior over hundreds of millions of years. In detail, the collision with the asteroid, which was about 100 kilometers in size, led to an enormous heat surge that spread through the moon's interior to the opposite side. In doing so, it also affected the region that is now known for its numerous Maria and the creep terrain. This process ensured that titanium-rich magma accumulations were transported to the side facing the Earth, similar to how a surfer is carried along by a wave. According to the simulation, the heat released and the subsequent mantle convection were sufficient to explain both the extraordinary creep enrichment and the basalt-rich rock of the Maria. What's more, the impact at the moon's south pole may have even triggered the volcanism, and thus the formation of the Maria in the first place. The event presumably concentrated heat-generating elements on the near side of the moon. This interaction of radioactive heating and increased mantle convection may have literally fueled the upper mantle of the near side over millions of years. Consequently, the hot magma was able to penetrate to the surface in huge eruptions. According to experts, the first eruptions occurred about 200 million years after the asteroid impact. However, the most intense phase of the Maria volcanism did not follow until 300 to 500 million years later. The bottom line is that the South Pole Aitken Basin and the nature of the Moon's front side are apparently directly connected, and that one of the greatest lunar mysteries of all time may finally be a thing of the past. And we hope that in a few moments, clicking on the subscribe button will also finally be a thing of the past. Become part of our community now and never miss a new video from our channel Digital Discoveries. We'll see you soon.